Today we're going to discuss our experiment involving springs. The purpose of our lab was to see how the energy of an object is affected during the motion of a spring in a two-dimensional space. We used a coded model to replicate that spring in an experiment multiple times. Some physics fundamentals for this lab to understand are the minimum principle, energy principle, and some other key concepts you'll see later on. And here are the results of our lab. Our predicted results was that the kinetic energy and potential energy of the spring would rise and fall throughout the duration of the experiment. As one rose, the other would decrease, and vice versa. And as you see, we have an X and Y position graphs on the right. And I know these are not energy graphs, but think of it as a roller coaster. As you are going up the ramp, the potential energy is increasing. And when you go over the hump, the kinetic energy increases, which would result in the potential energy decreasing. We had no errors. Now what we did was that we videoed a spring with a weight on the end, which was allowed to move in a two-dimensional plane, and then we obtained the data using Tracker. And then we replicated that data using GlowScript. But here's our video. Now, the first part of the code is where we initialize most of our variables. We first initialize the mass, and then we initialize the initial conditions of our weight, which was the initial position and the initial velocity, as you can see. In the second photo, we initialized the gravitational constant and then our spring constant that we found. We then put in our rest length of our spring and then the stretch length as it was released. Excuse me. And then we gave us the change in length of the spring. And then we found our initial energy of our spring, or of our, weight when we released it. As you can see, the formulas we used are on the left. And the kinetic energy was 0 because when we released it, the velocity of the object was 0. Here is where we actually started to do some more work. First, we found the initial and final momentum of our experiment to calculate the net force later on. And then we calculated the force of gravity. We then used momentum to calculate the net force, as we said we were going to do, and then we found the spring force by taking net force and adding the gravitational force to it. We then made the code which would run our trajectory of our object through its oscillation. As you see, we have the velocity update formula and the position update formula, which are there on the left. And then we have our spring length and then our spring change in length. And that made the trajectory, which we used to calculate our energy, which way we have our kinetic energy, potential gravitational energy, we have our spring energy, and then we have our total energy. And we had the energy formulas on the left. Now here is the models that it produced us, or our graphs that it produced, and we do have errors. We could not correctly get our data to go into the code, even though our TA said we were doing it correctly, which is strange. But here's the results of that it gave us. It gave us that our change in energy was a straight upward go, which it should not have been. It should have stayed in a range where it was constant, where it should not increase or the energy of the total system should not have increased or decreased. And then there is our change of position, which should have been oscillating like it was before. Obviously, we also had errors with our model. It should have oscillated instead of going in a straight line, which it did, which is strange. Now, our system was the weight, while the surroundings were the spring and the world around it. Now, our two what does it mean questions. First, was the energy principle correctly defined in our experiment? And it was not, because our energy did not remain constant throughout the entire time. Our total energy changed, which is strange, and it did not remain the way it should have. Now, our periods of oscillation. Our X had a period of oscillation of 1.3 seconds, while our Y had an oscillation time of 0.9 seconds. And this means that the the Y was moving much faster, and this might be due to the help of the spring force and the gravitational force on the weight. We performed this experiment to see how the energy changed throughout through the oscillation, and the results were that the energy changes is indirectly proportional to one another. And we did have slight errors when we were putting the file into our code, but we know how it should have happened. Thank you.